lights go in.
Okay, so stop it. We are ready in our notes. This is 5.4, number 4. And this is actually kind of good practice for our quiz. Because on the quiz, you will need to solve an equation. Now, it won't have a 2x in it like this one, but it will be an equation that will do a lot of the same things. If you watch the notes video, we did a couple of these in the notes. The difference was, in the notes, we were solving in degrees. Now we're solving in radians. That doesn't change a thing about the way we do things. Okay, so here we go. Look on your formula sheet, your reference sheet. You should have a formula for cosine 2x. On the sheet there are 2 theta. And you actually have 3 of them. See, there's 1 and then there are a couple more that I hand wrote on there. Any of those can be used. So look at your problem, particularly this guy right here. Which version of the double angle cosine might be the most conducive? Jake?
I wasn't raising my hand, sorry.
Oh. Does anyone want to raise a hand? Brayden?
The third one?
Which one is that?
2 cosine squared.
Exactly. We want to use the one that's just a cosine. Look at your versions, kids. See how one of them is a cosine squared minus sine squared? And one of them is 1 minus 2 sine squared? Those will work. You will eventually get the right answer. The problem is, the problem already has a cosine in it. So isn't it nice if we just keep it all cosines rather than throwing some sines in there? So 2 cosine squared minus 1 plus cosine. Yep, anybody can move if you want to be in a place that's more light. We got a couple seats over here. Now, I plugged it in. This could be a quiz question. Now, at this point, this could be a quiz question. How do I proceed with this equation? Well, I'm going to factor it. Before I factor, I'll probably rearrange so it's in a little bit better order for me to factor. You don't have to do this, that's completely optional. But when it's in the right, I call this the right order. Do you see what I'm saying? Yeah. And I think it's easier to factor that way, but that's up to you. So how does this factor? I'm gonna have to have a 2 and a 1 cosine. And I'm gonna have to have a 1 and a 1, right? Minus plus. So that when I FOIL it all back together, I end up with a positive cosine in the middle. Okay? Now, we set them equal to 0, so this one ultimately is going to say cosine equals 1/2. And this one is going to say cosine equals -1. This is like your quiz. You're going to have to be able to do these things. Okay? Okay. I have to have this on, sorry. I'm the walkie-talkie in this hallway. Okay, so where does the cosine equal 1/2? Well, where does it equal positive? Quadrant 1 and also 4. Because cosine is x, and x is positive on the right. So cosine is adjacent over hypotenuse. So that's a 1, that's a 2, this then is a √3. What kind of angle is that right there, that reference angle? It's a 60, but I'm in radians this time. So 60 is 1/3 of 180, so pi over 3. So my reference angle is pi over 3. So since that's quadrant one of my answers will be pi over 3, right? Quadrant 1. What about the one all the way around here in quadrant 4? It's 5 pi over 3, and for those of you that are wondering where that came from, it's 2 pi minus pi over 3. So it's 2 minus a third, which is 1 2/3 or 5/3. If we were in degrees, this is 60 and 300, if we're in degrees. Okay? Hello. Okie dokie. Now, where is the cosine -1? Well, that's somewhere on the circle. How do I know it's on the circle? Well, think about if it were a triangle. Is it possible to have a triangle where adjacent and hypotenuse are the same? No. No. So it's on the circle. Cosine is x. X is -1 right here. And what angle is that? Pi. So pi over 3, 5 pi over 3, and pi are the answers to the question. That's actually really good quiz review, because other than the very first step, that's exactly what you're going to need to be able to do on your quiz. All right, let's look at the next one.
Should we light a candle?
Oh, we could light a candle, but I think there's laws against that. I don't know.
There's laws against lighting a candle.
In a classroom, I think there's some kind of rules about it. I don't know. I don't know. Yeah. Okay. First thing we have to do is get rid of this. So look on your sheet. You only have one option. Sine 2x is 2 sine cosine.
Okay, so someone in technology go, that means that the door panel is not plugged into the emergency outlet that's right there with the switch.
Pardon the interruption. Please try to continue to keep all students in the classroom. Please try to continue to keep all students in the classroom. Restrooms are being monitored, so if a student does need to use the restroom in an emergency, you may allow that, but please try to send them one at a time and have them return directly to class. Thank you.
All right, what do we do with this? This right here could be a quiz question, okay? Not the first part, but this part right here. What do you think?
Subtracts 2 sine.
Exactly. We're going to subtract 2 sine x. Do not divide. Always subtract. And then, once you subtract, what can we do now? Look at it. What can you do? Take out, we call that factoring. We can take out a 2 sine. And what will we have left if we take out a 2 sine? Cosine minus 1. So what does that mean? Set them equal to 0. What does this tell me? Sine equals 0. Or cosine equals 1. Those are both going to be on my circle, aren't they? So sine is y. Where is y? 0.
0 and pi.
0 and pi. Cosine is x. Where is x? 1. already have it written down. So that's it. Those are my answers, 0 and pi. All right, anybody have a question about those two problems? Good with that? Okay, now, we're gonna shift gears a little bit, still using some of the same ideas, but these problems look a little different. But there's one of these on your quiz too. So this is actually really good review for us, if we're doing it. Sine alpha, and if you don't like the alphas and betas, you can change them to x's and y's or a's and b's or whatever you want. So sine alpha is 3/5, and alpha is between pi over 2 and pi. Cosine beta is 5/13, and beta is between 3 pi over 2 and 2 pi. And we're gonna find the sine of alpha plus beta. That exact question could be on your quiz, because that is a formula in 5.3. C and D are in the 5.4. So we should be able to do this. So Jake?
On the top, like that's alpha, right? The alpha is in quadrant 2.
Yep,
Right.
so this tells you where you can draw your triangles. So our triangles, alpha will be drawn in quadrant 2. So this is a picture of alpha. It's in quadrant 2, 90 to 180. And what do I know about this triangle? Opposite is 3 and our hypotenuse is 5,
Yeah.
which means I can do the Pythagorean theorem,
4.
and it's actually -4. Please watch your signs. If you're not in quadrant 1, something will be negative, right?
Yeah.
Okay. Do the same thing for beta. Where's beta?
4.
Quadrant 4. And his cosine adjacent over hypotenuse, 5/13.
Yeah.
So we'll do the Pythagorean theorem. You may know that one. If not, 5 squared plus y squared is 13 squared. So 25 plus y squared is 169, y squared is 144. So it looks like that is -12. Now, caution. Every problem isn't gonna work out with nice whole numbers. Is it clear to you we could get radicals? Yeah, we could get radicals, no big deal. Okay, so we have drawn a picture of our given. We've done the Pythagorean theorem to complete both triangles. And now, I'm gonna write the formula for this. So
I do not see the plug that he's
on
talking
your
about,
sheet.
the door, the mattress.
On the sheet, that might, I don't know, is that a U and a V or something, or?
Yeah.
Okay, don't let that worry you. The formula says it's the sine of the first, cosine of the second, plus cosine of the first, sine of the second. That's the formula for the sine of alpha plus beta. Everybody see that off your sheet? So the formula has 4 numbers in it. And the numbers are gonna come straight from your pictures.
Okay, protected by CFC box? Yes. I don't see a plug coming out of that.
I'm missing a plug somewhere. All right, so sine alpha. Sine alpha, what's the sine of alpha? Look at your picture. 3/5. What's the cosine of beta? 5/13. Cosine alpha, -4/5, and sine beta, -4/5. negative 12/13. Now, these are multiplied, okay? So we're gonna multiply those and get 15 over 65. I know you could cancel, but don't, because we're gonna end up adding, and it's nice to have that common denominator. So just 15 over 65 plus 48 over 65. And that's gonna equal 63 over 65, and that's the answer to the question. Got it? Okay, now, the next, all these problems on this page use this same setup, so I've gotta leave that up there. Now I need tangent alpha minus beta. All right, so find the formula for the tangent of alpha minus beta. Tan of the first minus tan of the second over 1 plus tangent of the first, tangent of the second. All right? So, no thinking involved there. We just go straight to our reference sheet, pull it off. That's the formula we need. Now, take the numbers from the picture and plug them in to the formula. So what's the tangent of alpha? Negative 3/4. What's the tangent of beta? Negative 12/5. Over 1 plus, negative 3/4, negative 12/5. Everybody okay with that? Okay, so now, you can proceed however you want. I'm gonna kind of clean up what I can clean up. So negative 3/4 plus 12/5 over 1 plus 36/20. And again, don't reduce it, just leave it 36/20. Is that okay with everybody? I just did a little minor cleanup work. That's a complex fraction. You can proceed with it any way you want. My personal preference is I look at the whole problem, every piece of the problem, and the common denominator for all of it would be 20. So I'm going to multiply everything by 20. Because what that will do is cancel every fraction. So 4 goes into 20 5 times, so this is a negative 15. 5 goes into 24 times, so that's a plus 48. There, nothing cancels there, so that's 20. Those are completely gone, plus 36. Now, you do not have to do the problem that way. Somehow you have to deal with all those fractions. This is what I like to do. Now I can see my answer is 33 over 56. All right, we're gonna get through a couple more and then we'll do some review. Everybody still with us here? All right, here we go. I guess all I really need is a picture, so I'm gonna erase all this now. And we are going to do the next problem, which is cosine 2 alpha. Now, again, we've already drawn the given. All that sort's still there from before. Now I just need the formula. So this is one that has 3 versions. No one cares, doesn't matter this time. So which one do you want to use? Cosine 2 alpha is?
1 minus 2 sine squared.
1 minus 2 sine squared. That's the one she picked. Alright, so here we go. 1 minus 2. What's the sine of alpha? That's alpha. The sine of alpha is 3/5, and we have to square that. So This is 2 times the sine of alpha squared. So the sine of alpha squared is 9/25. And timesing it by 2 is 18/25. Remember, you're multiplying by 2 over 1. So 25/25 minus 18/25. Did you get 7/25? And that's what you'll get no matter what formula you choose. She picked this one. You could have done 2 cosine squared minus 1. You could have done cosine squared minus sine squared. It doesn't matter. All right, last problem. Cosine beta over 2. All right, what's our formula for cosine half angle? Plus or minus square root of 1 plus cosine over 2. Again, there is nothing to understand there. Here's the problem. Find the formula on the sheet. Now, pick your numbers from your picture and plug them into the formula. So plus or minus, what's the cosine of beta?
-5 plus.
Cosine?
Oh, 5/13.
5/13. Now, you gotta clean that up. How you do it is your choice. Me, I'm gonna multiply everything by 13. That's what works for me, but that isn't what you have to do. You can do whatever you want. So I end up with 13 plus 5 over 26, because that cancels. So I end up with plus or minus 18/26, the square root of 18/26. Now I think I will reduce it, because when I reduce that, I actually get 9/13, and it's kind of nice to have a 9 under there, because I'm square rooting. Square root of the top is 9, square root of the bottom is square root of 13. So that one's easy to rationalize. Let's stop right there, make sure everybody catches up. But we are gonna have to deal with the plus or minus. Okay, it's kind of all over there. Did you follow all that? You got it? All right, now we gotta decide if it's a plus or minus, and this is a little bit tricky, so try to pay attention, try to follow along. In the very beginning of the whole problem, we were told that angle beta is between 270 and 360. Now, I changed that to degrees. Is that okay with everybody? So angle beta is between 270 and 360. The question involves half of that. So if whole beta is between 270 and 360, then half beta is going to be between what? 135 and 180? Now, where is 135 to 180? Which quadrant are we talking about? Talking about right here, right? You are doing a cosine problem for an angle in quadrant 2. Are cosines positive or negative in quadrant 2? Negative. Cosine's x. X is negative in quadrant 2. So you are going to choose the negative root for that problem. If this had been a sign problem, then you would choose the positive root, because sine is positive in this quadrant, but cosine is negative. Wow. Okay. All right, so enough of that. Enough of that. So that homework, 5-4 is going to be due on Friday, Tuesday. Okay, so 5-4 is going to be due on Tuesday. So here's what we can do at this point. All right, we're not done. We're going to keep going. But here are our choices. You can do some review problems. We can do a homework. We could like get out the 5-4 homework and work through that. I don't care. We can do 5-3 homework. We can do whatever you want to do. So 5-4 homework? Yeah. All right, let's do 5-4 homework then. Please work along with me, because if we get all the way through it, then you don't even need to turn it in, okay? So let's see if we can get all the way through the 5-4 homework. All right. First one says find the exact value of the sine of 15 using the half angle identity. So, if we back up a second, a quiz question might be find the sine of 15, and you would probably do 45 minus 30 or 60 minus 45. But you can't here because it says you've got to use a half angle identity. So, would you agree, well wait, first before I do that, would you agree that 15 is half of 30? And your formula says, whoops, that the sine of half an angle is plus or minus the square root of 1 minus cosine angle over 2. That's the formula on the sheet. Letter might be different, but that's the formula. So for us, what is our x? What's our x, or what's our variable for us? 30. So plus or minus 1 minus cosine 30 over 2. So then we gotta figure out what the cosine of 30 is. You can do that. What's the cosine of 30? Root 3 over 2. So this is, I think we had one of these the other day, where we have radicals under radicals, and we're not alarmed by it. It just happens. So you do what you want to do. I'm going to multiply everything by 2. So I'm ending up with plus or minus the square root of 2 minus root 3 over 4. The top is the top. There ain't a darn thing I can do with that. But the square root of 4 is 2. So I can at least do that. And then what do I have to ultimately do? Do I want the positive or the negative? Now, this angle is known. This is not like the last problem we did where I didn't know what my angle was. I know my angle is 15. Is the sine of 15 going to be a positive number or a negative number? Positive. So we want the positive. All right, is everybody okay with that? It's a mess, but are you all right with it? All right, 1 minus 2 sine squared. Look on your reference sheet. 1 minus 2 sine squared is a formula for something. 1 minus 2 sine squared is a formula for cosine, not cosine squared, cosine twice something. Well, what's the something? 53. So this is a formula for the cosine of 106. Everybody making sense with that? Square root of 1 minus cosine, what is that, 13 over 2. All right, 1 minus cosine, forget the number for a minute. What's 1 minus cosine over 2, square root? That's a formula for sine angle divided by 2. What's our angle? 13. So this is a formula for the sine of 6.5. Okay, this one is tricky. This one is tricky. Look on your sheet. Do you see a sine squared minus cosine squared on your sheet? What do you see? You don't see that, but what do you see? You see the other order? So what if I factored out a -1 from this? Then I would have cosine squared minus sine squared. Right? If I pulled out a -1, it would turn that around. What's this a formula for? Cosine twice something. So for us, it would be cosine 72. But remember, we had to pull out a negative, so it's actually negative cosine 72. It's the opposite, because it was in the backwards order. Okay, you guys still with me?
Yeah.
All right, next we have an equation to solve. We're going to do it in degrees. See those directions there? We're going to do it in degrees. I need a formula for sine 2x. Sine 2x is 2 sine cosine. I also, what am I doing with tangent? Tangent is sine over cosine. That looks a little interesting. Any thoughts on that? I heard somebody say get a common denominator, and that's perfectly okay. Keep in mind though, this is an equation. So I am actually allowed to clear that fraction. Think about this for a second. If you had 2x plus 1/2 equals 0, could you times everything by 2 if you wanted to? So I'm going to multiply everything by cosine. Now don't freak out. The rule is you can't divide by a variable. You can multiply. There's nothing wrong with multiplying by anything you want, okay? So if I multiply everything by cosine, I'm going to have a cosine squared, and then minus sine equals 0. So I'm multiplying this by cosine, and this by cosine. So that's how I got 2 sine cosine squared. That canceled, and that's still 0.
Factor out sine.
Factor out a sine. And that leaves me with 2 cosine squared minus 1. And then what do I always do after I factor? Set an equal to 0. So either sine equals 0 or 2 cosine squared minus 1 equals 0, which means 2 cosine squared equals 1. Cosine squared equals 1/2, and what do I do with that? Square root it. So cosine is going to equal plus or minus the square root of 1/2, which is 1 over root 2. cosine plus or minus? Everywhere. What kind of reference angle has an adjacent one and a hypotenuse root 2? 45. So you got 45s in every quadrant. Can you figure out what those are? 45. 180 minus 45. 180 plus 45. And 360 minus 45. We're not done. Everybody okay so far? Everybody understand where those numbers came from? That could be a quiz question. Okay, we're not done because remember this guy, we still have to deal with him. Our other factor. So that's going to be a circle. Where on the circle is the sign, which is y, 0? 0 and 180. So we've got to add those to our list. So all that is the answer to that question. All right, we're going to get this done. All right, anybody have an issue with any of that? Okay, last one is one of these ones where we have a bunch of given, figure out first. So here's my alpha. Alpha is going to be in which quadrant? 1. And the tangent is 3/4, which makes the hypotenuse 5. All right, that's easy. Where's beta? 3. Secant. Make sure you don't make the 13 negative, you guys. I know it's negative in the problem, but isn't the 13 the hypotenuse?
Yeah.
And hypotenuse is never negative, so it's the 5 that's negative there. I did this one earlier. That's going to be negative 12. If you don't know that, and you may not, and it's perfectly okay, you'll do the Pythagorean theorem, right? To figure that out. What am I trying to tell you? Sine alpha plus beta. Okay, what's my formula for the sine of alpha plus beta?
Sine alpha cosine beta plus cosine alpha sine beta.
Exactly. Yeah, you know what to do. Plug them in. Sine alpha. Cosine beta. This looks really familiar. Cosine alpha. Sine beta. Negative 63/65. All right, so you don't need to worry about that. Everybody, don't turn it in. Don't turn it in. Everybody that's here today. Okay. Max. Max, you were here for all that, right?
Yeah.
You filled all that out?
Yep. I have my notes too.
Oh, yes, I need to check that. Your notes and your practice quiz. Okay, so now we don't have much time left. Is there any,